This video is a continuation of nomenclature of alkanes, and here we have some condensed structures. We're going to break down the process to convert these condensed structures into skeletal structures. We're going to name them. It really doesn't matter what order you do that in. You can name them directly from here, but I think one common strategy that we'll use is to tease out the longest continuous carbon chain. Okay, so this first question is presented with parentheses. There's parenthesis here, there's one over here. It's branched, so the way it's presented to you is one thing. The way you manipulate the structure before you name it is something else. So you should always try and rewrite it as long as you can, and that will allow you to name it accurately. So I'm going to write this again, ignoring the hydrogens, just focusing on the carbons. And I'm looking for the longest continuous chain. So before I do that, I'm just going to try and recreate it carbon by carbon. So if I see a parenthesis, I typically look at the carbon immediately outside the parenthesis, and that would be my branch point. So I'm going to start with this carbon here. So I've got 1, 2, 3, 4, 5 carbons. So 1, 2, 3, 4, 5. So again, I've got this carbon through that carbon. So then to the left, I've got 2 lots of this. So that would be 2 lots, 1, 2 lots of C. Well, I'm ignoring the hydrogens. So I just caught myself trying to do a hydrogen. I just have C, 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 C. So again, if you look here, this cluster of 2 carbons and this one, both attached to this carbon. Well, that's exactly what we had here. We had 2 clusters of 2 carbons attached to this carbon. Okay, so now I've teased it out. Then 1, 2, the third one in, which is this one, I've got a carbon above. So let's put that back in there. And then my end carbon that I drew initially, I've got a carbon coming down. And then another 2 carbons. And then right at the end, I have 2 single carbons. Okay, so again, step 1, faithfully strip this structure down as accurately as you can. Well, accurately, it's not as accurately as you can. You either do it accurately or you don't. But strip it down, take all the hydrogens away, see what you're looking at. Now, let's try and, now the game is to try and look for the longest continuous carbon chain, which becomes the branch. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That seems to be the longest continuous chain. There's no other. Now notice it wasn't presented in a completely straight way. It was all curled and looped, and also notice part of it was hidden in this parenthesis. That's why it's hard to eyeball the longest chain if you don't look at the parentheses. Parentheses are not always buds. They're oftentimes here part of the branch. So we've got our branch, and anything that's not in the branch is now a bud. So I've got a bud, a bud, a bud, a bud. Single carbon buds are methyl buds. So I've got methyl, 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 and I've got a 2 carbon bud, which is ethyl. Okay. Again, notice that upon a naive inspection, it looked as if I had 2 buds, right? If you just look at this, you'd say, oh, there's a methyl bud here, and it looks like a propyl bud. But no, when you re-inspect, you realize that what you thought was a propyl bud is really part of the longest continuous chain. Okay, so let's put a line between this one so I don't go over that line. So I know that my longest continuous chain at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 has 10 carbons. So that's decane. And at this level, at this introductory level, you won't be expected to go beyond 10 carbons. So we've got 10 carbons here. I'm going to reverse alphabetize so that when I read it correctly, it will be alphabetized. So methyl comes next. Methyl decane is all one word. But I have 3 methyls, so I put trimethyl. So now trimethyl decane is all one word. But I have to tell people where the methyls are. I want to, when I number the branch, I want to hit the buds as quickly as I can to give the buds the lowest possible number. So I notice that if I start numbering this way, I hit a bud on carbon 3. If I start numbering this way, I won't hit a bud until carbon 4. So that locks in the numbering. So I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, I would number it this way to hit those buds as quickly as I can to get them the lowest possible number. Okay, so now I've numbered. Those methyls are on carbons 5 and 7 respectively. 2 of them are on carbon 7. So it would be 5, 7, 7 hyphen. You have 3 methyls, you need 3 numbers. It doesn't matter if 2 of them are on the same number. You have to indicate where every single bud is. And now I've got an ethyl bud. And the ethyl bud is on carbon 3. So that's my completed name. So this structure is 3-ethyl 577 trimethyl decane. If I wanted to construct the structure from the name, I would just write out 10 carbons. You would typically, in fact, let's do it right now. So we went from the structure to the name. If I had to go back from the name to the structure again, you wouldn't have to draw it in a bent form like this. So I'm just going to quickly erase this. Okay, if we had to go back again, we would just write out 10 carbons. Number them. Doesn't matter at this stage because you haven't put any buds on. So we'll just randomly number them this way. Okay, 10 carbons. I've got 3 methyl buds and they're on carbons 5, 7, and 7. Again, single bonds can twist, so it doesn't matter if you put them 3 up or 1 up and 2 down. At this point, it doesn't matter. So 5, I've got a methyl bud. 7, I've got 2 methyl buds. So on 5, I had 1. On 7, I had 2. And then on carbon 3, I have an ethyl. So that's my connection of 2 carbons on carbon 3. So you've gone from the name, you've interpreted it backwards, you've got your structure. Single bonds, not only can they twist, but they can bend like a string of spaghetti. So that's why there are a whole host of bent ways it can be presented to you. But what you can do with a bent piece of spaghetti is you can always straighten it out again. And you may as well do that when you inspect it. So let's produce the skeletal structure. So I've got a 10 carbon backbone. Each dot is a carbon. A line is connection between two dots. So 2 carbons, 3, 4, 5, 6, 7, 8, 9, 10. So there's our 10 carbon backbone. On carbon 3, I have an ethyl bud. So 1, 2, 3. Again, I'm trying to maintain a honeycomb. So this could have been over here, but you want to try and maintain that hexagonal arrangement if you can. On carbon 5, I have a methyl. And then on carbon 7, I have 2 methyls. On carbon 7, you have no choice but to deviate slightly from the honeycomb shape. But again, the honeycomb is a rule to live by, not a rule to die by. Okay, so structure to name back the structure. Let's have a go at the second example. So we have this structure here, and we have another parenthesis, so let's have a look. So I'm going to start with this branching carbon here. I have a carbon above and a carbon to the left, and then below I have a carbon with another carbon. Again, I'm just stripping it down of all of its hydrogens. Then I have 5 carbons, so this parenthesis 5 just means you've got 5 adjacent CH2 structures. So that would just be 1, 2, 3, 4, 5. And then I have a final carbon right at the end. Okay, you can inspect it, make sure you haven't lost anything, but that seems to be the structure I have. The longest chain, let's see, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. So actually, what looks like the longest chain is not. The longest chain seems to include this bend. So again, oftentimes you can make a mistake if you don't correctly identify, well, you'll always make a mistake if you don't correctly identify the longest chain. It's not always the one that looks the longest, it's the one that's actually the longest, and it might take some inspection. So again, originally it looked like it was this and we had buds, but actually you see that one of these things was part of the chain of the branch itself. So I can see I only have 2 buds. They're both methyl buds. Both methyl buds. So my longest branch has 9. The buds seem to be this end of the structure, so I'm going to number it accordingly to make sure the buds have the lowest number. 4, 5. So I know that 9 carbons is nonane. 9 carbon alkane nonane. I have 2 methyl buds both on carbon 3. So methyl is just methyl. 2 methyls is dimethyl. All one word, dimethyl nonane. And they're both on carbon 3. So 3, 3 hyphen dimethyl nonane. This is pretty linear, so you could rewrite this if you wanted to. Let's do that just to be consistent with above. So we've gone from structure to name. Let's go back from name to structure. And this time I'm going to leave the original. I'll just get rid of these scratchings that I used to generate the name. So if you were doing this reverse process, you went from this, you would have 9 carbons. You could number them. 6, You don't have to recreate the bend. Number them, and on carbon 3 you have 2 methyls. So that's how you do it. And let's write the skeletal. So you've got 2, 3, 4, 5, 6, 7, 8, 9. There's our 9 carbons. And on carbon 3, you have 2 methyls. So that would be the skeletal structure of 3,3-dimethyl nonene. And finally, just tilt this down a bit, let's go for the last structure. So here, let's see, we've got 1, 2, 3, 4, 5, 6, 7, 8 carbons that look like they're all connected. Okay, so that's these guys here. And then if I come 3 in from the end, I've got another 3. So 3 in from the end, I have what looks like another 3. And then if I come 4 in from the other end, so from the left side, 1, 2, 3, 4, I've got another 3. Okay, so this is the bent piece of spaghetti structure I have. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that like reverse S shape. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've got a couple of 9s. An 8, a couple of 9s. I don't think I have anything larger than a 9. 1, 2, 3, 4, 6, 7. 1, 2, 3, 4, 5, 8. Yeah, so it looks like 9 is the longest continuous chain. 2, 3, 4, 5, 6. Okay, so 9 seems to be the longest continuous chain. So it wraps around that way. And then I can clearly identify my buds. The buds, so let's see, from this side I've got 1, 2, 3. The bud is on carbon 4. And if I count this way, 1, 2, 3, 4, the bud is on carbon 4. So if we don't have symmetry because the buds are different, but you have the same number. If you were to hit the bud from either end of this branch, you would hit a bud on the same numerical carbon. So which one would you pick? You would just favor alphabetization. So if this is an ethyl bud, because there's 2 carbons, and this is a propyl bud, then you would favor E over P. So we'll try and get to the E bud. If we both hit them on carbon 4 potentially, let's favor E over P. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a very random rule, but that was a rule that was chosen randomly out of a choice of 2 possibilities. Not randomly by me, but by the IUPAC. Okay, so we have our 9 carbons, so that's nonane. So that's nonane again. And I'm going to reverse alphabetize, so I want to have the P and then the E, so when it's read forward, the E comes before the P. So I have propyl nonane, all one word, and the propyl is on carbon 6. So 6 propyl nonane, and then on carbon 4 I have ethyl. So the structure is 4 ethyl, 6 propyl nonane. And let's do what we've done here. let's get rid of this twisted spaghetti presentation. Let's go from the name to the structure in a more elongated form, and then we'll write the skeletal structure. Okay, so if I saw this, I'd say, okay, 9 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9. Number them. On carbon 6, I have propyl. So that's 3 carbons branched out of carbon 6. And then on carbon 4, I have an ethyl. Doesn't matter, again, single bonds can twist, so it doesn't matter if you have 2 of them going that way, this way, directly up, or pointing down, it doesn't matter. So that's what we'd have. Let's draw the skeletal structure. So I have 2, 3, 4, 5, 6, 7, 8, 9. So that's my 9 carbon backbone. On carbon 4, I have ethyl, so 1, 2, 3, 4. 2 carbon branching out of carbon 4. And on carbon 6, I have a propyl bud. And again, so long as you're trying to trace what looks like a honeycomb, that will be a good indication that you're drawing this in the correct way. So these are just some more examples of alkanes going from structure to the name, and vice versa from the name back to the structure.